Let's start with some terminology. You may have heard these terms from various products that we have produced. NLS means National Language Support. For everybody outside of Informix, National Language Support means all the languages around the world, English, European, Asian, Middle Eastern, Thai. But at Informix, we limited that meaning of the term to just the European support that we've had in our 6.x and up through our 7.1 products. So if you talk to somebody outside of Informix, they'll use the term NLS to mean all languages. ALS was a term created in our Singapore development office standing for Asian Language Support. There is no European support in ALS products. It supports the markets of Korea, PRC, Taiwanese, Japanese, and Thai. Well, actually, Thai is a separate product that is not under the ALS banner. Because NLS, the term NLS was used for just European support, we at Informix had to create a new term to mean all those languages, including Asia and Middle East. So we created the term GLS. But even within that term, people wanted to use that as the generic term for internationalization, but then they wanted different levels. So we've defined 5 different levels of types of internationalization. One is 8-bit cleanliness, 8-bit clean. That's just a very passive approach. It's just saying that you don't strip off the top bit of character data. That is really not an aggressive approach into markets outside the United States. Level 2 would be supporting English and the European languages. Level 3 would be Japanizing your product for the Japanese market. Even though this is not a goal for Informix, because our goal is obviously level 5, we see this on third-party products that we license occasionally, that they will be tuned for the Japanese market. That will mean that they won't work for Taiwanese or PRC or Korean. But we define that as a level just to give those products a way to be characterized. And then level 4, which is where the 7.2 server is, that's all of Asia. That's PRC, Taiwanese, Korean, Japanese, and then all the European languages and English also. So the 7.2 product is not specific to just Asia, it's not specific to Europe, it's not specific to the United States, it includes all of those languages. And then level 5 is Middle Eastern and Thai. The reason that those are broken out is that there's special display issues, mostly in the tool side, but even though the server produces utilities that act like tools, so there are some issues in the server product regarding to Middle Eastern and Thai, and 7.2 does not fully support Middle Eastern and Thai. I'll talk a little bit more about that. Yes?
I have a question on that.
Yeah.
On level 3, 4, and 5, I mean, other than just the messaging, it's a little different between the languages. What else is there? There's nothing like 16-bit.
There are some significant differences between languages and territory, cultural conventions. I'll talk about those later in the presentation, but there are some significant differences within those categories.
Yeah.
Just to continue on with terminology, we use the term locale a lot. And locale is an environment that embodies the requirements of a particular language, a particular territory, and a particular code set, and I'll talk about the issues surrounding all of those, and I'll talk about the code set at some length. An example of a language, territory, and code set would be the English language in the United States, code set ASCII. Okay, that's an example of a locale. Another example of a locale is the French language in Canada using the ISO 8859-1 code set. The process of localizing a product is to make a product work for a particular locale. That's an example I gave before of Japanizing your product, taking a product and making it work for the Japanese market. Now, if you take that to its extreme, you would create one product for the Japanese market, one product for the Taiwanese market, one product for the French market, the German market. You can see how that explodes out of control, given all the languages and territories and code sets we need to support. So what we have done, and that's the main focus of what 7.2 server is internationalize our product. Create make the software work for many locales. And the number of locales is based on the level that I talked about, the GOS level. So our 7.2 product has been internationalized for English, Western European, Eastern European, Asia, and so forth. Just to give you a history of our Informix products, we have had the products we've needed in the market for some years. A long time ago, we gave our source code to a company in Europe. They made it work for European support, and we merged that back into as part of 6.0 NLS, and I'm carrying that forward to this day. We gave our source code to the Mideast, a company in the Mideast, a distributor there. We have yet to merge that fully back into our product. We gave our source code simultaneously to Japan and the company in Taiwan, and both of them created a separate product. Later, the Japanese product was merged into the 5.0 ALS. The 5.0 ALS product merged Japanese requirements into the same product with the PRC and the Taiwanese and the Korean, and then Thai still sits there out as a separate product. The goal of 7.2, as you see, is to move that product that has the Japanese support, the PRC support, and the Taiwanese support into the base US product. From this, you can see how there's a difficulty with maintenance and support of 6 different products. So by reducing the number of products down to one product that is produced, when you fix a bug in the US product, you fix it for all languages. And that makes Informix's internal life a lot easier. Okay, I talked about a locale being a combination of language, territory, and code set. So let me describe the types of issues, and this is getting to your question, Raymond, about what are the differences for different languages and what are the differences for different territories. For a given language, you want to allow the user to type in the characters that they are familiar with in identifier names. So if somebody creates a table name or a column name in the United States, you can type in an English identifier, SQL identifier. Well, in Asia, you should be able to type in an Asian name or a European name in a European code. So the characters that are allowed in identifiers, such as SQL identifiers, ESQL for C and ESQL COBOL identifiers, in internationalized products have been changed so that they can support the particular language that the user is working in. Collation, that involves string comparisons and character comparisons, as well as sorting. Different countries, different languages sort data in a different way. Even if they're using the exact same characters, they sort data in a different way.
You mean the sorting process is also in local languages?
Yes, the sorting process is also in local languages. For example, the French sort differently than the Germans, who sort differently than the Norwegians, who sort different, and obviously sort differently than the Japanese and the Chinese, who use a completely different alphabet. But even countries who use the same alphabet or similar alphabets sort data in different ways.
Wait, is the data stored in English or is it stored in Japanese?
It's stored in the data in the database is stored in Japanese characters or French characters or Chinese characters or German characters. And as I'll show you, each database is branded with the language that data is stored in and the sorting order that the data is stored in. So if you're a French customer who enters a list of names to, say, generate a phone book in the database, you would enter those names, and if you did an order by using the French locale, you would get them sorted the way that the French person would expect them to be sorted.
So you can actually type in local language certain strings and it will go match with the database.
Right.
And return in the order which expected to.
That's right. Order by here. Order by would return the order of the local language. The string comparisons, like where column 1 is greater than some literal string would be based on the collation order of that particular language. Yes.
So languages that have, say, more than one type of script, like Japanese, would you normally just pick on one easily internationalized one, like katakana or something?
No, the Japanese market expects katakana, hiragana, and kanji to all be supported. And those three alphabets have a sorting order in Japan relative to each other.
So it can cope with symbolic type languages which don't necessarily just have vowel sounds and...
Absolutely, absolutely. That's the big problem in Asia, is that languages have ideographic characters where each character represents a concept rather than a building block in which you can create words that correspond to concepts. And as a result, the ideographs there's thousands of them because there's thousands of concepts in humanity. So you can't fit all that in a single byte like you can in English or in even European characters. So because you can't fit the bit representation for a character in a single byte, that gives rise to a lot of software problems that we have to solve in an internationalized product.
So you actually localize everything, including the data as well.
That's right.
The actual data.
That's right. And that is really the prime goal, is to make sure that users can write applications from a mom and pop shop in another country where they can type in the data that they are comfortable with.
So how do you sort characters in the form of a concept? Or how do you sort them?
Well, Asian languages have this idea of a radical order or a stroke order, if you're familiar with some Asian languages. The way that the character is constructed, it may be more dense than other characters, and the less dense characters, I don't speak a foreign language, so I can't give you a complete answer, but for example, in Chinese, there are characters that are associated with water, or characters associated with the earth, or characters that are associated with your hands or your feet. And there's groups of characters that are associated with that, like lifting or pushing. Those characters would sort together, for example.
Mm-hmm.
But in terms of our products, we don't really have to care from a development point of view how that sorting is done. As I'll show you later, the definition for how to sort is externalized from our product in a separate file that the product refers to.
Oh.
And we can change that order, so we don't hard code this order, and it changes for the particular locale that you're working with. And I'll go into detail on that. Okay? In addition to what characters are allowed in identifiers and collation, alphabetic case conversion is another rule that changes from language to language. There are some additional lowercase or additional uppercase characters in some languages, and those need to be case converted. Languages like Japanese have this concept, which you can even see in English, the concept of equality being different than a equals lowercase a. An example in English would be an extended version of that, which would be case folding. Lowercase a can match against lowercase a, and it can match against uppercase a. Okay, that's a convenience that we have in the English language for extending the match. Our current product does not do that right now. Our 7.1 and the previous product does not do that. It is literally lowercase a equals lowercase a. This extended match is which we're putting in for the Japanese market. We have made it in such a way that you could do things like case folding. There's this idea in the Japanese language and maybe in other languages about an equivalence class, where a set of characters are equal. Like you mentioned, the Japanese alphabets or the Chinese alphabet, and Japanese in particular, have 3 different alphabets. 2 alphabets are phonetic alphabets. One of the alphabets is an ideographic alphabet. I don't even know if you can call it an alphabet, but it's ideographic. But the ideographic represent the concepts, the phonetic represent the sounds, which can be built up to represent concepts. So the customers may want to match the sounds to the ideographs, or the hiragana and the katakana may represent the same sound, so you may want to match the sound, the hiragana letter ka, that sounds like ka, to the katakana letter that sounds like ka. So those two form an equivalence class that the Japanese customers want to match, which is very similar to our case folding matching. So that's why we didn't implement it specifically for Japanese. We put the we say put the rules for equivalence classes in a locale file. So that's what we've done in extending matches. Also, another issue that you're probably most familiar with is the translation of message text. When you have an application that has a menu or buttons or error messages or diagnostic messages, those messages need to be translated into the local language. So that when somebody brings up a screen that says Informix development environment, they want to see it say Informix development environment in their own language. So what we have to do is make it so that it's easy for for our localization centers to translate these messages.
So all the front-end tool would have to be kind of rewritten just to adapt that OS format in certain way.
Yeah, well, when you say front-end tool, we're also including utilities, which, for internationalization purposes, are just like each individual separate product. Okay. They have to be rewritten in the sense that all messages or all text that are printed out need to be externalized into a separate file that is not part of the binary, so that somebody can translate those text files and ship those text files and then point to a different set of text files given the particular language.
But that's one thing. How about when it comes on display? I mean, the size and all that. We have
Font issues, yeah, you're right. Font issues are, if you're in a GUI environment, you have to scale because, say, Asian characters take a larger space.
Yeah.
But in a GUI environment, Asian characters are no different than even English characters because depending on the font that you use for English characters, the font may be big and it may be small.
Designed itself.
The product has to respond to even changes in the English font, so Asian data doesn't really, give any more problems than English data in that regard. In a character environment, there are specific issues for Asia because what Asian OEMs have done is rewire existing ASCII terminals to support kanji characters, so they make one character fit into two display spaces, and we have to deal with that issue.
Who is in the charge of taking care of those? I know that you're in the charge of, getting GLS into the engines. Who's in the charge of those tools? Should they realign and stuff?
The individual product groups are responsible for their product. We have made significant contributions to providing common requirements, common software that is used across products, and also we have worked with the product development groups to supply resources to help them do that work.
Great, thanks.
In the past, there was a different model in the past where product, as I showed the picture, the product was shipped off to some other country who did the work and then either sold it separately or tried to ship it back to the United States. The problem with that approach is that each one of those groups made their changes in different ways, so that has presented a significant problem for us to GLSize our product because the European way was different than the Asian way, but yet to merge it into one product, you had to make it consistent and yet backward compatible with both of those. Okay? The issues regarding territory, and this is more maybe retitled the cultural requirements. Even within the same language, French in France and French in Canada, for example, there are different date formats. Date format in Canada is different than in France, even though they speak the same language. We're retaining the old DB date for backward compatibility, but we have added a new environment variable called GL date, which addresses the full range of European and Asian date formats. Okay? The same with time. The old DB time environment variable is still there. We've introduced a new GL date time, which extends, which supersedes DB time. Even though I don't know if we're putting it in the documentation, but I think eventually we're going to try to phase out DB time. And we haven't done quite the same approach with currency or money formatting. We're retaining the old DB money, but enhancing it to support Asian money formats and all the European money formats. And of course, all that description of all that is in the GLS Voyager 7.2 function spec and will be in the customer Before I go into the code set issues, or the issues that a product has to deal with in regards to code set, let me explain what a code set is and the various ranges of code sets. A computer understands bits and bytes, ones and zeros. So even a character, which is printed very, like something you would read on a piece of paper, is stored in ones and zeros. Unfortunately, over the years, there has been very little standardization of the encoding of the ones and zeros associated with individual characters. First example is ASCII and EBCDIC. If you're familiar with the IBM mainframe environment, EBCDIC is one way of encoding A through Z, 0 through 9, upper and lower case. And ASCII is another one. They're both single byte code sets that store everything in English, store all the English characters. Then there are a series of code sets for Europe and the Middle East. They are all 1 byte per character, and there's tens of them. IBM has its code sets, HP has its code sets. Sun follows some ISO standards. There are multiple standards for these different representations for European characters. In Asia, same situation. Multiple ways of representing the same set of characters. Taiwan is an extreme case of that. There's 5 or 6 or 7 different code sets that represent the Taiwan set. The unique aspect of the Asian code sets is, as I mentioned before, is they require more than 1 byte, in some cases more than 1 byte per character to represent that character. The reason that they're called multi-byte is that the ASCII character, the English characters, are still stored in 1 byte. But the Asian characters, most of the Asian characters are stored in 2 bytes. Some of the Asian characters are stored in 1 byte. It depends on the particular code set. So as you're going across a string, you have to determine whether this is a 1 byte character or a 2 byte character. So you can have a mixture of English and multi-byte, English and Asian. One of the biggest questions I get from these salespeople is, somebody has the Japanese product, can they store Japanese and English? And the answer is absolutely yes, because the basic code set allows you to store both Japanese and English. Every code set that we supported in Informix supports English and 1 or more other languages, or 0 or more other languages, because ASCII supports just English. So if you say a French code set, it has all the characters that are in ASCII, and encoded in the exact same way as in ASCII. All the Asian code sets encode the first 127 characters exactly like in ASCII. So English and another language is never a problem. However, if you want to store, say, Chinese and French in the same code set, you have problems. There are many code sets that have language groups, like a Western European, which will have English, Spanish, Italian, German, French, all in the same code set. So within those languages, you can store characters from all those languages in the same database. However, if you are going across Turkish and Greek, which cannot be represented in the same 1 byte code set, or French and Taiwanese or Japanese, there is only one solution for that, which was espoused by Unicode. Okay? The concept of a code set that contains all the languages that anybody who would buy computer software would be interested in. Okay. Right now, Unicode is only implemented on Microsoft NT, so that really does not apply to the 7.2 Voyager server project, but I wanted to give you some background on this because this is probably the second most asked question. One of the characteristic of Unicode is that it contains a lot of languages, all the European, Western, Eastern European, the Middle Eastern languages, all the Asian languages, and it jams them all into 2 bytes per character. And it's 2 bytes per character even for English. So lowercase a and capital A take 2 bytes. And they're represented like the byte values are 0A, the ASCII character is 0B. So you have null bytes in the middle of strings, and the strings are terminated with 2 null bytes. That presents problems for applications that have been written from existing applications that are thousands and millions of lines of code, is retrofitting or breaking that assumption. It's bad enough in our products that we have to break the assumption that 1 character equals 1 byte, but breaking the assumption that a single null byte is the null terminator is really something that is a hard assumption to break. So we don't support Unicode in Voyager. However, what do the customers really want? The customers want to store diverse languages in the same database. There is a variant of Unicode, a compressed version of Unicode, which is a multi-byte code set which has the exact same properties of all the other Asian code sets, which is called UTF-8. It represents all the same characters that Unicode represents, but represents them in such a way that a single null byte is the null terminator. So it doesn't break the assumption of that a lot of our software and a lot of the operating system software makes about the makeup of strings. So we do support in 7.2 UTF-8. Both of Unicode and UTF-8 are in a class called universal code sets, the idea of one code set that supports all the different languages. The other advantage of UTF-8 over Unicode, one of the problems with Unicode is because it's 2 bytes for even English characters, character data would immediately double if you stored Unicode in the database as 2 bytes. Okay? So I call UTF-8 a compressed Unicode not only because it doesn't have that property of a single null byte not equaling null terminator, but it's compressed. The ASCII characters are 1 byte. So all the English databases would stay the same size.
Do you know how widely UTF-8 is being accepted compared with Unicode, for example? Or is it a kind of subset of Unicode?
No, it's an alternative to Unicode. They both represent the same characters, but they have different bit representations for each character. It's just like it's like the difference between any other code sets. Same characters, but just represented in a different way.
Right.
Okay. The take-up of Unicode has been very slow because of this fact that for existing software you have to retrofit. People who are starting software from scratch are interested in this because then that gives them a basis to start developing software. But existing applications are really hesitant. And as a matter of fact, UTF-8 never existed until people started to try to retrofit their software to Unicode, and they just said, we can't do it. We need an alternative where we don't break all of our assumptions. From our customer's point of view, they don't have to care what we store internally in the database. For example, a customer may be typing in one Asian code set that is neither Unicode nor UTF-8. If we convert that down to Unicode and store it in our database, then somebody coming in with a French code set can go into UTF-8, and they both can coexist in the database. So if the customer wants that type of environment, we give them that environment. And they don't care, they don't have to care what's inside because the appropriate conversions are done to make that happen. Even if you, and like I said, even if you use Unicode, because we deal with terabytes of data, a lot of the people that are espousing Unicode are not in the database business, okay? So the size of databases would increase. So you have to have some form of compression anyway. You have to compress Unicode in some way. So somewhere you're going to have to do a conversion to make your disk space adequate. UTF-8 gives you that compression, and it also gives us the opportunity not to re-implement our entire set of products to support a universal code set.
So 7.2 supports all of those different code sets?
Except Unicode.
Okay.
For 2 reasons. One is because we didn't want to re-architect the product, and second of all, 7.2 is not on NT, which is the only living operating system that supports Unicode. NT also supports all the other code sets, but Unicode is yet another code set that you can use on NT.
You're saying 7.2 won't import it to NT?
I am in a development project that is developing 7.2 for Unix. I have no idea what the NT team is doing. So I'm not making a statement about what NT product plans are. 7.2 Voyager, codename Voyager, is not, its target platforms are Unix platforms, not NT. There may be NT product plans, that's not the project we're working on. Okay, now that I've described code sets, let me describe the issues involving code sets. As I mentioned before, multi-byte string processing, when you have code sets that where one character does not equal 1 byte, you have to make the determination as you step across a string, how many, where is the next character, or how many characters do I have in the string. So it's transparent to the customer. The Asian customer would say, oh, well, I have my Asian characters mixed with my English characters, and it all works. So it's not this is not a fancy feature for the customers, it just works. The exceptions to the logical character processing a character as a character rather as, or a string as a series of characters rather than a string as a series of bytes, the exceptions to that are length. You might want two types of length. You might want the number of bytes in a string and the number of characters in the string. Because our memory allocation is still in bytes. If you say char 20, you still get 20 bytes. So there may be reasons for the customer to want to know how many bytes are in a string in terms of memory allocation. But if the user is doing character processing and not just buffer management, then they'll want to know how many characters in the string. We have to provide two types of length functions. Substring is another exception. For various technical reasons, the indices in substring are still byte indices, which cause problems for multi-byte data, but those are described in the Voyager documentation.
When you're going to use code, then it'll be always 2 bytes. I guess that would be an advantage.
That would be an advantage.
Yeah.
There are, well, from an implementation point of view, you don't have to use Unicode to get that benefit. You can store a multi-byte code set internally, not in the database, but as you're processing it in a form which gives you that property. That's called a wide character form. Okay. So any multi-byte character can have a wide character form that has that property of a fixed width character.
Just for my clarification, when you say multi-byte, you really meant 2 bytes?
No, I mean multi-bytes. Multi-byte means 1 and 2 bytes.
But there's no more than 2. I mean, there's no more than 2 bytes.
No. Oh, okay. Well, in some Taiwanese code sets, there are 4 bytes per character. So there are. It doesn't mean that there's 2 to the 32 numbers of characters, but there are characters in the 2 different Taiwanese code sets have 4 bytes per character.
But we do not support anything more than 2 bytes.
We support 1 through 4. So we support everything. We haven't seen a standard that supports more than 4 bytes, that specifies more than 4 bytes per character. But we store 1, 2, 3, or 4. I mean, once you store 2, it's really, programming-wise, it's just it's not a big leap to go and. In a client-server environment, you may be connecting to a, if we talk about Voyager and leave Windows out of the mix right now, you may be connecting to an ESQ4C program on one Unix operating system, say an HP, and to a server on another Unix operating system, say Sun. They may represent characters in a different way. They may use different code sets. So if you say that there's a character called A umlaut, that is stored using 1 numeric, 1 bit encoding, and you pass that across the server, across the network to the server, and store that in the encoding of the client, if you try to print that out on the server, you will get a problem unless you do some type of conversion. That is the idea of code set conversion. If, of course, you are on the client, you pass the data to the server, and then you immediately pass it back to the client, you don't need to do code set conversion. Customers need to look at their architecture, client-server architecture, and say, when I print out data, where am I printing it out? Am I going to print it out on a combination of operating systems such that there's different code sets? If so, they have to define what the code set of the database is going to be, and then if they do that, and I'll show you how they would do that, we would do the code set conversion of data going into and out of the server. Okay. So for example, if the client and the database have different code sets, you may want to do code set conversion there, or if the database and the server environment have different code sets. you may want to do code set conversion. Of course, you want to avoid code set conversion if you can, because it's a processing. It takes some processing time, and that's where customers would have to do some system analysis. First, determining what code sets they want, what languages they needed support for, which would determine what code sets they need to support, and then determine the different hardware and what code sets are available on that hardware, and so on. Okay, so those are the different issues, and I'll go into some more detail on those later. But let me talk about the architecture we have used to implement these types of features. I've alluded to these earlier in the presentation. In general, the processing for the locale, the language, territory, and code set requirements are not hard-coded in the executable. We isolate those in a separate file. An example is, I'm using an English example and then one step generalizing. If you wanted to check out if a character was lower, one of the old ways you would do it is compare whether it's greater than or equal to A and less than or equal to lowercase z. Well, you can see that that would not work in French, where A accent is not even in that range, but it's still a lowercase character if you're a French customer. So one of the ways to internationalize that is to call a function like is lower on X, and then is lower would refer to something else to tell it what the lowercase characters are. Well, that works for European, fine, but for Asia, we needed to GLS-ize that. We needed to take it one step further to provide a GLS version of is lower, which would return the correct result for multi-byte code sets and single-byte code sets. And that function refers to a definition of the lowercase characters that is not hard-coded in the product itself. It is externalized in a file. So the product knows nothing about what the lowercase characters are. All it knows is that if it calls this function will return true or false based on whether this character is a lowercase character for the environment the user has specified. So, in detail, the requirements have been moved to what are called locales or code set conversion files. Locales describe the language and territory rules, and the code set conversion files define how to perform the code set conversion, which byte values are equivalent to which other byte values. And there's an announcement. Yes?
Does that mean, I don't know if you're coming to this later, does that mean that an ESQL-C programmer is going to follow a specific set of guidelines when he's developing an application which talks to the server? In other words, calling particular functions to make it international?
Right, that's a very good question. What does the ESQL-C programmer do? Because they face the same trouble and the same problems that we faced in creating an internationalized program in the C language that we used to implement Voyager. We use internally to Voyager a internationalization library called the GLS library, which has functions like GLS is too lower, and a whole suite which implement the different types of language, territory, and code set differentiations. We have decided, for scheduling reasons, not to include the GLS library as part of the ESQL-for-C programmer's API. So for Voyager, the ESQL-for-C programmer will still have to follow the rules that have been defined by the operating system on which they are writing. The reason we created the GLS library is because different operating systems have different function calls, and those function calls behave differently, and they define the languages differently. So we ourselves could not write a portable, internationalized server product without the layer that we have provided in the GLS library. Customers won't be able to write a portable, internationalized product. They will be able to write an internationalized application for HP, or an internationalized application for Sun. They would have to do the same work that we did on abstracting that internationalization across platforms. We are looking at making that available in future releases, but there is no promise that that would be there. So they will still have to call the operating system version of the internationalization functions. It presents a confusing situation because the operating systems have done work on internationalization, so customers can write internationalized programs, but those applications are not portable to those applications will not be portable to the range of operating systems that Informix is concerned about. Not only are we concerned about the entire range of the Unix operating systems, but we don't want to have to rewrite programs for NT and rewrite programs for Windows 3.1 and OS2 and Mac, and whatever operating systems we're on. So we had to create this portability layer to make it easy for the developers to bridge that gap across different platforms.
He's got a point because not only is PLC, I mean, like common languages like C that's been worked on for decades may not be portable across other platforms either.
We have had customers who have requested access to the GLS library, to buy the GLS library, because they have the same problems that we do, trying to create a product for multiple countries on multiple platforms. There's, as far as I know, there is no solution for that. That's why we had to create the solution for ourselves. There is no solution for them to go out and buy, and they were interested in buying it from us, but it is not a sellable product. We're only currently using it for our internal purposes. So if each one of these locales and code set conversion files describes the language territory and code set characteristics, the customer has to then has to refer and announce what locale they want to work in. So there's a set of environment variables that I'll describe later, which points the executable to a particular locale. The customer will say, I'm French and in Canada with the ISO 8859-1 code set. Please operate in that environment. So that would refer the Informix executable to that locale, and then it would operate in French, Canada, ISO 8859-1 requirements.
Can I ask you a too detailed question, then?
Yes.
Which source directory have you used the GLS library for most stuff in German language?
Well, the GLS library is a new library that is common to all directories. However, GenLib and OSLib frequently now make calls to the GLS library.
How can you make sure that all the appropriate calls are GLS first before they were to act? I don't know how to describe that. I mean,
well, it's a significant development effort to identify all the places where we have broken the assumption about one character equals 1 byte, or date formats are limited to the values in DB date, or there is no code. Yes, client and server both speak ASCII. It's a significant development environment to identify that, and that's what we've been doing in Voyager, is identifying those places and calling the particular GLS library function to implement that behavior in the places we have identified.
if you want to localize the data, that's pretty much like everywhere.
Absolutely. The GLS feature, we did an analysis. It touches only 2% of the code, but 20% of the files. So it showed if it was 20% and 20%, that would say it's concentrated, but it is spread across many files. Few changes would spread across many files. So there is a GLS library directory, but there is no directory that implements GLS. It is really a common piece across all components. The closest example I can think of is ANSI compliance. ANSI compliance is not a feature, it's a coding standard. Internationalization, GLS, is not a feature, it's a way of programming. And as a result, it affects all different components. So, just as when you fix a bug in an ANSI-fied product, you have to make sure that that bug fix conforms to ANSI. In any place, you have to make sure that that bug fix supports GLS and internationalized rules. Any place you make that change. previous slide I talked about generic internationalization issues, the internationalization architecture. Let me describe the particular architectures for the different products that have been produced. The NLS architecture, which was, as I showed, the European changes merging into 6.0 and its family, and then carried forward to 7.1. Internally, they don't call GLS library functions like I had mentioned the GLS products do. They call the XOpen internationalization functions. Those functions refer to locales that are specific to the OS. Sun has its set of locales, HP has its set of locales, DEC has its set of locales. Every vendor seems to have different names for those locales. IBM will call it FR_FR. Sun would call it French. HP would call it, or Sun would call it FR, HP would call it French. The contents of those locales are different, and then they're proprietary to that operating system. The customer chooses the locale to use, this announcement mechanism, via XOpen defined environment variables.
Yeah, but all the backward processing was done in English. This NLS thing is not done in local language. The sorts are not done in local language.
The nchar data type sorts according to the language specified in the locale. The char data type sorts as byte value order, but the nchar data type was provided so that that data type will sort in the localized order. And other character comparisons will happen in the localized order. The where clause on nchar data will happen according to the sorting order of the locale. XOpen doesn't clearly define a code set conversion, a set of code set conversion functions and so forth. So the code set conversion that is done in the 6.0 and the 7.0 are via a table that is referred to by an environment variable called DB API code. The details you can find in your NLS documentation. And that table is only for as maximum of 1 byte code sets, so 256 characters. The 4.0 and the 5.0 ALS architecture calls specific Informix ALS functions that work for Asia. The functions refer to ALS, Informix ALS environment variables. The locales are chosen using ALS environment variables that are specific to 4.0 and 5.0 ALS products, and the conversion is hard-coded in the product. Okay. So the ALS product is internationalized, the locales are internationalized for the 4 Asian languages, Japanese, Taiwanese, PRC, and Korean, and the code set is hard-coded. So that product is a mixture of a localized product and an internationalized. The 6.0 ALS architecture changed slightly because at the time that that product was began, we knew that we were going to put the GLS into 7.2, so we started doing some work toward moving towards that. Instead of calling the ALS functions, we called the GLS functions. Okay, those are functions referred to Informix GLS locales, not operating system locales. The locales are chosen using a set of GL60 ALS environment variables, and the code set conversion is not hard-coded. It was changed, so it isn't hard-coded, and it is via GLS library code set conversion tables, which could support more than the NLS code set tables, more than 1 byte per character. So the GLS architecture, you can almost guess what it was going to be. It calls the GLS library functions. Those functions refer to Informix locales. Now, for backward compatibility with NLS, inside an NLS database that is sitting out there in a European site or customer site is the name of the operating system's locale. So what we have to do in 7.2 is provide locales that are compatible with the different languages on the different operating systems, so that when a customer wants to upgrade from an NLS database to, or not upgrade, they can continue to run as before with the GLS. And then not only do we provide the locales for backward compatibility, The problem with those backward compatible locales is they have different names for the same language and territory and code set and different contents. So one of the reasons for providing GLS is to give customers compatibility in a heterogeneous client-server environment. So we have to provide locales that are the Informix way of French, just saying that we are French in Canada, ISO 8859-1. So if the user specifies that GLS locale, they will be able to be compatible in the client-server environment. The client will use the same name as the server, and they will know that they have the same contents. The locales are chosen using the Informix GLS environment variables. I'll talk a little bit more about those, but those are obviously in the documentation. And code set conversion, once again, is done via Informix tables for NLS backward compatibility, but via the GLS tables for sort of forward-looking and also for the Asian code sets, because the NLS code set conversion tables only support a single. How does this locale architecture or this abstracting of locale information out into separate files deal with the installation? I know the tech support first calls you always get, most calls you get are product installation. So I want to describe how things will change in that regard. An internationalized product is one set of executables for all the bundles that I mentioned, but it's still one set of executables. Because of market requirements and sales requirements and price uplifts in different countries, we wanted, from a development point of view, obviously, to ship all the locales and the code set conversions with the product. We have one product. But the various Asian countries needed separate products for their market. So the first bundle that we will produce is these executables, the single set of executables that I've described. Locales for English, European, and Middle Eastern locales. Code set conversions for European and Middle East. And the translated messages and the translated documentation will not be bundled with the base product. Because of time, it takes a long time to translate all the online messages and the documentation. So those as they have always been, will be shipped as separate products. Free products, but separate products. Well, I'm not sure if they're free. As separate products, which have been called language supplements over the years.
So does that mean that a feature like the GL date time, for example, which would be an enhancement for a customer in the US, for example, it means you can display your date time in a different way.
Yes.
That would be built into the core product. They wouldn't pay any extra for some kind of GLS support. That would be built into whatever upgrade they get of online.
Right. Well, let's take that example. Say that our own customer wanted to enhance their date in English in the United States. Well, before they've had DB date to do that. Okay. We provide a new environment variable called GL date.
They sometimes complain because they can't change their date time, for example. They can change the date format, but not the date time.
DB time. DB time. Okay. DB time is an environment variable that will change the format for date time in limited contexts. We have not expanded the context in which you can express. The GL date time is saying we will expand the languages you can express in the areas that DB time currently changes, but we are not expanding the scope of DB time. That doesn't mean that if there's customer requirements like that, I had not heard that customer requirement, we could look at that for future product releases. Because I was quite disappointed that DB time has such a limited effect. The bundles, okay, that's the first bundle that goes out. The bundles 2, 3, 4, 5, and 6 are the same set of executables as shipped with bundle 1, but bundle 2 has the Japanese locale, bundle 3 has the Taiwanese, 4 PRC, 5 Korean, 6 Thai, and then the Japanese bundle will have the Japanese code set conversion, and the Taiwanese bundle will have the Taiwanese code set conversions. There are no code set conversions for PRC, Korean, and Thai because there's only really one code set that those countries have, so there's no code set conversion to be done. So there's no code set conversion tables to be supplied. Unlike the European products, the translated messages and the translated documentation will be bundled. So the Japanese product will contain the executables, the Japanese locales, the Japanese code set conversions, the Japanese translated messages, and the Japanese documentation. Let me give you some examples of what the locales are from even a more abstract level. They're not changeable or, maybe that's not the right term, addable by the customers. So we are, at this point in time, not giving the user the opportunity to change the locales. We're distributing the locales in a form that is not encrypted. It's not really a binary form, but it's not something that they can change. Okay. This is for the benefit of tech support, because we had felt that until the entire tech support organization becomes familiar with this concept of GLS, having them trying to get up to speed and customers changing their locales and modifying the way that their program works would make it almost impossible for bug reproduction. So we're only delivering a set of packaged locales that we provide to our customers. So we're not giving them the ability to create locales like we can or modify locales. However, if there's a big enough customer that really knows what they're doing and we can send an SE out there, or we can hold their hand, or they know exactly what they want and they give us the requirements, that locale could be built and sent to them. The reason that we have to be careful about distributing locales and the ability to create locales around the world is this architecture, in a sense, because these rules are not hard-coded, we are in a sense externalizing the source code of Informix products. It's not in the terms of C code, but it is in terms of rules that affect the behavior of the product. So just as we give the users limited ability to source code access or the ability to modify our product, that's why we're not allowing them to change or add locales themselves. But there's various scenarios, like I said. We can sell them the locale compilers, we can sell them SE time, we can sell them a locale, all that kind of stuff. That's the advantage of this architecture, that you don't have to give them a whole separate product to give them a new language. Because our products will go out with a certain set of locales, maybe there's a variation, a new country springs up with new requirements, new combination of existing requirements. We can provide that without having to redistribute the entire product. Examples of locale names are in the Informix dir, there will be a GLS subdirectory in the 7.2 product, and there will be a directory called LC, and then the X I have on this slide refers to a version number. Because these locale objects are object file format, we occasionally change that object file format so that you'll see LC8 or LC9 or LC10 corresponding to a locale version, object version number. Because we install the same different products in the same Informix dir, and one product may be a new product that has a new version of the GLS locale object file format, and another product, we don't want to overwrite a locale and then screw up the access. So we have to version number these.
Or do you archive the text version of the locale something?
Yeah, there's a registry that we maintain internally of all of the locales that we have.
In
Yeah, oh yeah.
Okay. So even if we screw up one of those objects, we can use locale compiler to giving the versions and stuff.
Sure, but what scenario would we screw up on the objects?
Well,
we're trying to avoid that rather than provide the solution to fixing it afterwards. Well, sure, if somebody throws it away, if somebody deletes it as a file, you know, if somebody empties it out or something like that, yeah, that would cause arbitrary problems, just like if somebody deleted a .a or, you know, overrode a .a. Sure, that would cause problems. We could regenerate them. Just that the customer would not be able to regenerate them.
Right, definitely.
Now, this is where this is one issue for tech support elements in the future. If you find that you're having so many calls and you think it's a great feature, or you're having customers call you and say, I want to change my locale, how can I do that? And you can handle the support of the locale compilers in the future, we can put that on the base product tape so the customers can do the same thing that we can do. So that'll play out over time, but we didn't want to stretch our commitments in the first place.
See, otherwise they would have to get back to you regarding this specific requirement changes.
It's like any bug fix.
Yeah.
It's like any feature enhancement. The only advantage of this is that we can turn around that feature enhancement or that bug fix a heck of a lot faster than going through a whole porting cycle and all that, because these LCO, locale object files, are portable across Unix and Windows and NT. So, if you got a bug fix, then you got a whole patch team and a whole maintenance cycle and all that stuff. We of course would have to put in a process so that the locales don't go flying around the world to random customers and random versions. But it's a lot faster turnaround to solve a customer problem than it would be for a C code change that requires a rebuild and retest of the whole system. Okay, so the names of these locale object files look kind of cryptic, and it's because of the 8.3 file format name. And these products are on Unix, but we need the same names. The whole point of the GLS library is to have consistent naming and consistent contents across in a heterogeneous environment, and that includes DOS, Windows 8.3 format. So EN is an ISO standard abbreviation for English. US is an ISO standard abbreviation for United States. French, Canada, Japanese, Japan. There is no standard for code set numbers. Code set names, I've thrown out a few like Unicode or Japanese shift-JIS or Taiwanese Big 5 or EBCDIC or ASCII. There's really no standards body that defines those names of the code sets. So what we've done is the next best thing is we've glommed onto the IBM code set numbering scheme, and where IBM does not number code sets that we need to support, we have to add numbers for them. So what you'll notice is the numbers, because of the range, this is a hexadecimal number, a 4-byte hexadecimal number, 4-digit hexadecimal number that corresponds to a 16-bit integer. The numbers that begin with an E are in the Informix defined range. Like this is E006 is for shift-JIS, which is not registered in the IBM CCSID numbering scheme, so we had to create our own. IBM has a create your own range, and the E's are in that range. This number 0333 is a hexadecimal number corresponding to the decimal number 819, which is the IBM CCSID. With the Voyager product will be a utility that the customers can run that will, for each one of the locales and code set conversions that we supply, will list the full name. Will list English, United States, CCSID 819, Japanese, Japan, shift-JIS. But just to let you know, what you're looking at is they're not encrypted to make it confusing, but they are confusing because they're encrypted, and it's because of the DOS restrictions. Code set conversions are in a separate file than the locales. Once again, they're not changeable or addable by the customers. We could just deliver new code set conversions to customers for bug fixes or enhancements. And examples are, once again, in the Informix GLS directory, CD with a version number. This version number could be different than the locale version number, so you may see CB7 and LC8 because the binary format of the conversion objects is obviously different than the locale objects, and so they can change at different rates. For every code set conversion, there's a pair of these files. From and to. This is from 0333 to 02B5, and this is from 02B5 to 0333. Once again, these are code set numbers, hexadecimals, representations of code set numbers that correspond to either a name or an IBM CCS ID, and then the extension .cd. So for every code set conversion between a pair of code sets, you'll have two files. There are hundreds of code set conversions, because as you can guess, there are tens of code sets, and conversion between code sets that represent the same characters is that's a big directory. So if you CD into the CV directory and then you do an LS, your machine isn't stopped. It's just there's hundreds of files. The messages have changed, not in their format, but where they're located. The old DB-lang environment variable is still retained for backward compatibility. Instead, if the DB-lang isn't set, there's a whole hierarchy of way messages are searched for, and it's really kind of, it will look confusing in the user documentation because the hierarchy had to adhere to the backward compatibility with the ALS, various ALS products, the various English products, the NLS products, and so forth. So there's a list of 10 different directories we search for to look for message files, when in actuality we really only need to look in one place, but there is a whole list of backward compatibility. The new way we're espousing is that when the user sets their client locale to say, this is the environment that my client program is in, that would determine the language, territory, and code set, and you would look in that area. The difference in the English product that you'll see is that no longer are the IEM files in MSG directory directly. They are just like any other locale in a language, territory, and code set subdirectory. So the English messages will be in MSG ENUS 0333.start.IEM. The French will be here. And so. It's the same with the English locale. English is not, in terms of locales and messages, they're no different than any other language. The rules for English are embodied in a locale. The rules for the messages for English are in a language-specific directory. The only difference in English is that we've done significant optimizations to give the additional features, yet keep the same English performance that we had before. But that, from a customer point of view, sort of an abstract point of view, English is just another language. What are the hardware and software requirements for a customer that are trying to run this? There's very little that you need. If you want to run a client application in, say, Japanese, you don't necessarily need a Japanese operating system. You need a terminal or a terminal emulator that supports Japanese. So we have people in my organization which do development on this, which have a completely English environment, but they have a freeware or shareware or purchased Japanese terminal emulator or Chinese terminal emulator that they run. You know, like it's like in the X term, there's like J term for Japanese terminal, or K term, and that's all you need. You know, so, and of course, if the terminal requires, if it's a terminal emulator and it requires a font, of course you need that font also, but that's assumed to be in the same package. There are other things that you may need. Obviously, if you're editing programs and you want to use the Japanese language or the Chinese language, you need a text editor that supports that. But that's not something that we care about, but from our product point of view. However, you may have customers calling to say, I'm trying to enter Japanese in my VI and it wouldn't work. Well, we don't make VI Japanese. They have to have that environment. That's the thing. File names, for example, we support, and also compilers. Well, let me talk about file names first. We support the product whether it runs on an operating system that supports local characters in the file names. For example, you obviously know you can have all the ASCII characters in file names, but some operating systems allow European characters in the file names. Some operating systems allow Japanese or Chinese or all kinds of Asian characters in file names. We support our product whether or not they have them. However, if they do support Japanese file names, and somebody has, in SE, for example, a Japanese table name, we write that out. And since the table name corresponds to a file name, we write out that file name according to the table name. So, but if it doesn't, if there is no support for the local languages file names, we map it down into ASCII. Same with compilers. We allow ESQL for C macros and various literals, like string literals and character literals, to contain Asian characters in the EC file. However, if the compiler does not support those literal characters in the C file, well, we do a mapping down to, you know, an octet/octal representation. However, if the compiler does support that, we let it pass through. We let the Japanese character appear in the character string, appear in the character string. That's so it makes it easier for customers to debug. So when the debugger prints out a source line, they'll actually see the Japanese characters. The debugging may be a little more difficult for customers who are writing a Japanese or European or whatever EC file, but an English compiler that doesn't understand those, we will map those down into octal representation. When they debug, they will see the literals and the strings in that octal representation. So they could get a local version of the compiler, but if they don't, that will make their debugging a little bit harder. Debugging like EDX stuff. I talked about announcement mechanisms. How do we tell? I showed the different locale files we have on the system. How do we point customers to the? How do we point how does the customer point the executables to the particular locales? Well, there's 3 different environment variables that really control this: the client locale, server locale, and DB locale. The client locale is saying my in Voyager ESQL for C program, or my server utility is running in this type of terminal, or it's going to be writing this type of file. So for example, you bring up DB access, which is a client interface program. It will look at client locale to determine how to process, data on the screen. DB load or unload writes files. It will refer to client locale to find out how it writes out those files, and what locale, what code set it writes these files out to. The server locale is a separate environment variable that says the server writes out some files directly to the operating system. The client locale may be sitting over on in extreme case on a PC or on another Unix machine, but the server is writing files to its host machine. So the server locale is saying, write out in this format. The reason you would do that is because if the server locale is different than the client locale, you write out a file here on the server, you VI that file, you try to read it, you want it in a locale that you have supported on your server. And the DB locale is the locale of the database. That is the environment variable that Create Database looks at when it tries to say, well, now that I'm creating a database, I have to tag it in a certain locale. I have to create my indices in a certain sorting order. What is that locale? What is that sorting order? That's DB locale is that environment variable. Like I said, it depends on your system architecture as to whether you make these all the same value or what combination you have, because you want to avoid code set conversion if you can. Yet at the same time, you want to make sure that you don't give wrong data. If code set conversion is not done right, it looks very much like data corruption. It's garbage. Data, if A umlaut on one machine looks like A umlaut, and you pass it over to another machine, and the byte value for A umlaut is the byte value for, like, the yen sign, the user is going to say, hey, wait a minute, I had A umlaut over here, and I'm seeing the yen sign over here. It looks like data corruption. So, customers have to be careful, and we are putting in adequate not disclaimers, but adequate warnings that they need to set these environment variables correctly. We have seen testing engineers have this problem even here, so that is something that the customers may screw up. The default values for English all fall through. There's no problem. Users in English don't have to set anything. I'm giving an example in English of what they would set to if you wanted all English, but they don't have to.
Since we are distributing that the concept conversion, I mean, not conversion, I mean, the environment file to them, if they would have set that incorrectly, so it would become an error for our end users, immediately get feedback, and we don't do that, right? The customer would immediately know this is not supported.
Right. Well, let me describe. Yeah, let me describe. That's a good point. And that will be. I'll answer that question in the context of these next two bullets. The default, which the user does not have to set, like I said, is set the client locale to enus.8859-1. You'll notice that the names that they set it to are not the exact same names as the file, because the file names, like I said, are so cryptic, and the user should never really access that file. They should only be referring to the locales through here, and we do the appropriate mapping of this more readable specification down to the file name for them. Server locale enus.8859-1 DB locale. Customer doesn't have to do anything to get these settings, but this is how you would set it up. Another example is setting the client locale to Japanese in Japan with the shift.js code set on the client. Okay, and this is a very common example in Japanese. That's why I put it on here. The server locale is UJIS, a Unix server, PC in PC terminal emulator. This is the code set of PC terminal emulators for the client, and the DB locale is UJIS. Okay, you set this environment up, and what happens? As you convert data, as you pass data from the client to the server, from the client locale to the database, you convert from shift.js to UJIS, going from the client to the database, and then back from the database to the client, you convert from UJIS to shift.js. If on the server, you're writing out information in the database to a file on the server, you would do no code set conversion because the code sets would be the same. That's why I say you have to sort of set up your architecture and determine where you really want to do your code set. You could say the DB locale is shift.js. Then you do no code set conversion between the client and server, but you would do code set conversion when you wrote out files to the server. So you have to look at what terminals are connecting to your database. If you've got, 100 shift.js terminals connected to your database and 2 UJIS terminals connected to your database, you want to avoid the code set conversion for the 100, so you would make shift.js your DB locale and then pay the price of the code set conversion for the minority. Now, in all these examples, notice that JAJP, JAJP, JAJP. You set that to something else, and it's not going to work. You'll get kicked out. Usually when you're setting these, that's not a problem. The problem is when you've already created a database, and you want to open that database, and your database locale says JAJP, but the database you're trying to open is not JAJP. Then you'll get I think you'll get a SQL warning or something like that when you try to connect. So the code sets can be different with one stipulation, that there exists a code set conversion. I mean, if I said JAJP 8859-1 and JAJP UJIS, there is no code set conversion between those code sets, so you would be kicked out for that reason. So the language and the territory have to match, and the code sets have to be code set convertible in these. Between DB locale and server and DB locale and client. Client locale and server don't have to match, but sort of by transitivity, the code set name and
yeah, they better match. So
yeah.
To get converted.
Right. Well, the code sets don't have to match. Well, the locale names all have to match, because if the client locale name, the language in the territory, the client locale and the language in the territory, the DB locale need to be the same, and the language and territory of the server locale need to be the same as the language and territory of the DB locale. Obviously, they all need to be the same. However, if the client locale and the database locale need to be code set convertible, you need to be able to code set convert between these two and code set convert between these two. That doesn't mean that there's a direct code set conversion between these two, but that's okay. That's a little bit confusing, but the code set conversion only happens between the client locale and the DB locale, and the DB locale and server locale, not between this client locale and
It's only a
server.
permutation of two, so
What's that?
it's only a permutation of two, we can figure that out.
Well, right, that's right. But it has tripped up some testing engineers who are new to this process, so if it's tripped up them, it may trip up our customers as well as other test support engineers. And my last slide is what is beyond 7.2 from a server point of view. I mean, this talk has been obviously centered around an introductory to internationalization and then the server issues. There's a whole other host of issues regarding client products, Windows products that merit another presentation. But beyond 7.2 for the server, some of the utilities like on monitor, there's a few other ones that are not international. Those are spelled out in the documentation. The idea would be DB cockpit. The idea would be to internationalize those utilities. One of the problems we have with those is that they were created by third parties.
So like on archive is not.
On archive is not. DB cockpit is not. On monitor is not. We wrote on monitor, but it's not internationalized because it has to be built with 4GL, and therefore you have to have an internationalized 4GL, which we are working on, but there's no way that the time frames would work to get that. We have an internationalized character-based 4GL for ALS. The problem is that there's additional work required to make that compliant with 7.2, so on monitor will not be internationalized. According to SQL standards, you could have a code set per column. Right now we have a code set per database. When you open up a database, it is JJP ShiftJIS or JJP UJIS. SQL standards say that it has to be a code set per column. So if we go to SQL intermediate level, that is a requirement of SQL intermediate level. That requires a lot of work, so I don't know how soon we would get that feature in, because that's a re-architecting of our whole column architecture. Collation, also, you could specify the sorting sequence for a column or even in a given query. You could say order by and use this collation sequence for that given query. Once again, that requires a lot of re-architecting in our internal database system. Although that is something that we are targeting for because our European customers have, obviously in the European community, many small countries that want to isolate data in different columns. This is still not code set or collation per row. I mean, that would be the ultimate because you can't, even in the SQL 92, you can't have a column with rows in different code sets. You can have a column in one code set and a column in another code set. Complete MIDI, TIE, and Unicode support. Obviously, when we go to NT, we would look seriously at what we need to do for Unicode. In 7.2 for Middle East and TIE, we will have TIE collation and TIE date and time and Middle Eastern date and time. Middle Eastern date and time, Arabic and Hebrew calendars are very different than the Gregorian calendars. But we're putting support in those. But there are other issues regarding display of Middle Eastern TIE characters. Middle East goes from right to left, and TIE is a composed character. The character is not just consisting of one set of bytes. Multiple sets of bytes in multiple orders can equal one character. Those are more display issues that obviously are, well, they're related to DB access and the utilities, which means that we would have to do something in Voyager. These really hit hard in the new era and other tools products for G. And then, like was mentioned before, exposing the GLS library for ESQL for C programmers so that our customers can write applications that fill the same requirements that our product does, which is portable across languages and portable across operating systems. And that will have to appear in the future. Anyway, are there any questions that you've been holding back, or?
I would like to find out where's the GLS later with respect to the code language. Right before the.
I'm going to turn this off, so I don't know what that is.
That's fine.
Okay. The way, internally, the architecture would be, you have the, well, this is kind of a difficult drawing to draw. Okay, you have the operating system down here, you have the server product making direct calls to the operating system, you have the genlib, oslib, and then these are not proportional because the GLS library is small in comparison to these other ones. But the server will make calls to genlib, the servers will make calls directly to the GLS library, and the server will make calls directly to the operating system. Genlib will make calls to the operating system, and genlib will make calls to the GLS library, and GLS library will make calls to the operating system. So that's the rough architecture. Now, of course, there's many, this little component here, this is spread across a lot of different directories, but a lot of the changes we have are related to genlib and oslib because we do a lot of character processing. Yes?
GLS support that you get with tools such as New Era, is that developed by the same group according to the same guidelines? Yeah, how tightly integrated? I know it doesn't have to be integrated in theory, but just wondering how tightly integrated that is.
Right. Well, any GLS question usually comes by my desk. So we provide the commonality across those different products. The areas where it will be different is Microsoft has rules, and you have to play by Microsoft's rules, or you have to invent it yourself. And what is the success of OS2 and all that for people who invented their own way of playing on Intel platforms. So Microsoft has those rules, so Bill Gates is the guy who really controls what happens to our products at Microsoft, not me. So still, we try to be as consistent as possible. At some point in time, which is the problem that we face, and anybody who does heterogeneous Microsoft to Unix client-server processing in an international environment has to worry about the problem of data coming from a Microsoft environment according to the Microsoft rules having to eventually go down into a Unix database following Unix rules. We have, in the GLS library, captured the Unix rules. We can also, you can write a locale that follows the Microsoft rules. That's why we created the locales as general as possible so that if we have to play by Microsoft, if there's some reason that we have to play by Microsoft's rules, let me write it down here. Okay. If this is a client tool on Microsoft products, and then this is really independent of 3.1, 95, NT, doesn't really matter. In one part of this, we'll have to play by Microsoft's rules, but eventually, somewhere, if you got Unix here, somewhere you're going to have to play, you're going to have to figure out what to do in this bubble. The GLS library can do one of two things. For products that we don't have to rely much on Microsoft, we can use a GLS approach in the entire product according to our locales. Okay. However, if we're forced, and which in most cases we are, to play by Microsoft's rules, at least for the GUI part of it, for the part that interfaces here, we could have a GLS/MS, a GLS locale that follows the internationalization rules of the Microsoft component, and then we can say here, the server uses that same GLS locale that follows the Microsoft rules. So with the locales, we can sort of morph ourselves to whatever environment we have to play in. In Unix, we can create that environment. In Microsoft products, we may have to mold to their environment. So the commonality comes from the architecture that we provided in the GLS library to decide for the given product, and the architecture of the given product and the product's reliance on the Microsoft way of doing things determines whether we can choose our locales freely on both the client and the server, or we have to mold to the Microsoft way.
But that you've got the room to make the adjustments as you go on.
Well, that's the thing. We have the room to make the adjustment in this box. And the only question is, how big is this bubble in relation to this, or how significant is this Microsoft-specific bubble in relation to this non-Microsoft specific bubble? But we had to make it general because if we said, and this is the problem why we created the GLS library, if we said we have to play by a Unix rule, say HP, HP locales, well, HP and Microsoft are not consistent. They don't talk, the Unix vendors don't talk, and certainly Microsoft doesn't talk with the Unix vendors on how to get together and determine the common API and common locale names and common locale contents. So unfortunately, we as software vendors have to bridge that gap between those two operating systems, and that's why we created the GLS library, so that we can mold one to the other. Fortunately, people like HP and IBM and Sun are more adaptable than Microsoft. Microsoft has different operating systems. They have the Chinese version of Windows or the Japanese version of Windows. And that has very specific hard-coded rules that you can't change.
Yeah. All right. I'm done. Next week, you shut that off. I can ask another question.
Any other questions?
Great,
Thank you very much.
thanks. Thank you very much.
Is this of a personal nature? Is that why we want
It's
camera off?
actually more of a request, actually.
Okay.
It would be nice if you can mail us a copy of GOS functions, which one were actually referenced by the library, and which ones were actually referenced by general purpose servers and RSM layers or other networking type of GOS libraries. So
I'm sorry, I don't quite. We have a description of the GLS library functions, categorized by their functionality. These are the functions for code set conversion. These are the functions for date and time formatting. These are the functions for currency formatting. These are the functions for case conversion, that kind of stuff.
Okay.
So we have them classified by that. And that document is publicly available in /programs /GLSlib. Now that describes the GLS library, which is, like I said, something that the users don't see. However, if you're going to give in SunOS, it's called /vol/.
But it would be nice if they could be categorized like roughly where they was mostly referenced by, like referenced by the general purpose library or referenced.
Yeah, well, right. As new era, then we may need a separate presentation for that because
that comes with a load of GLS subdirectory.
so not international. The new era is a pain in the ass. International. The new era is in the process of international. There may be. Okay. Maybe there's message files for Spanish and Italian and things like that. But when I think of internationalization,